let's look at the team software process. And by the time you come to the end, I hope that you'll understand the essential features of the team software process and understand why it works and what it can achieve. Now, this team software process was developed by Watts Humphrey, and I believe he did it pretty much by himself. The full story is that having developed the CMM, where you got the software, software development process, he then thought, well, hang on a bit, can the same thing be applied to a team of one? Just the one person, himself. So he applied it to himself and he found yes it could, and come out with a personal software process. Now that's not going to be covered in this particular series of talks. It's a talk for another time. Then he thought, what about a team? And decided that a team was actually different from a collection of people. There was things that a team themselves had to do. So he set about devising a team software process. In 2003, he wrote the paper, Why Don't They Practice What We Preach? And it's a great paper. If you can, track it down and have a look at it. But in that paper, he did note that one of the most intractable problems in software is getting engineers to use effective methods. The list is endless. Good design, design verification, code inspection, comprehensive unit tests, and so on. Even when there is clear evidence that the methods help, and even with strong pressure to use them, many engineers still do not do so. Now, this is true for students and for practicing engineers, and it seems to be true almost regardless of the engineer's experience and training. Now, I recently read a book, Black Box Thinking, which compared the record of improvement in various industries, and compared the air transport industry, which has got an extremely good record of improvement, with medical industry experience, which is poor. Crime fighting, I guess, also poor. Government policy, also poor. And here, Watts Humphrey, I can see what his dilemma was. To him, improvement was pretty good. I mean, he looked at the data and he took all sorts of criticism and worked on it. He was okay. But a lot of people resist the idea that they might be measured and found wanting, and so will resist any method that actually measures their performance and exposes their performance. Unfortunately, this is going to have to happen, and it has to happen in an environment that is supportive. It's called a just culture, where the culture is just. Mistakes are tolerated, recklessness is not. Now back to team software process. Team building is not obvious. Generally, when a group of engineers starts a project, they get little or no guidance about how to go about it. All right? If they're lucky, their manager or one or two of the experienced engineers will have worked on well-run project teams and have some idea how to proceed. But in most cases, the teams have to muddle through with a whole lot of issues they never quite understand and never resolve. And it's particularly bad in software development, because software development is largely populated by people who aren't not that good on their social skills. So there are some examples of issues that teams have to deal with, particularly at the start of the project. And there's a list there of 16, and these are the ones that Watts Humphrey listed out. Now, I've introduced something of this to teams of students when they're trying to build some software, and we deal with maybe the first 6 of them. There's a lot of them, all right? Now, the first thing is, what are our goals? And think, well, obviously we want to get to the end. Yes, but how? Do you want to have a good time? Do you want to learn a whole lot of things? Do you want to get a good grade? Do you want to develop the best product you could ever think of? Do you want to get it finished in time for Christmas? What's your goals? What are the team roles and who will fill them? Getting less important now with multitasking or multi-role teams, self-managed teams, and agile. How will the team make decisions and settle issues? Very important, because inevitably there will and should be conflict. I'm not talking about confrontation, I am talking about conflict, healthy conflict. And how is the team going to deal with these things? What standard procedures does the team want to adopt this is important. I've got a group of people that have different ideas of how to go about things. We need to settle on one way of doing something so that we're not arguing at cross purposes all the time. What are our quality objectives, and so on. You could read down the list there yourself. The important point is that teams do have to come to some agreement about a lot of these things. Now there's more to it than that, and teams do have two things that they do develop. One is called a transactive memory, and that is teams gradually build up who knows what in the team. Right? I may not know everything, but I know who does know, and I know who to go to, and everybody else knows what I know, or knows what I know about, and knows when to come and talk to me, and we can pool our expertise in that fashion. Now that transactive memory builds up particularly in the early phases of the project, but there's some evidence that as the project settles down and people specialize a bit, then the amount of transactive memory reduces again as people get separated from each other. The second phenomena is collective mind, and this is where people know who's doing what and what stage it's at and what it ought to look like and what they need to do to fit in and compensate. Now, this is becoming particularly important in agile teams, self-managed teams, where there is not a great deal of formal coordination, and where teams and people within the teams have to do much more informal coordination, and so they need to be aware of what everything ought to look like at the time, roughly, and what things closest to them ought to look like, and what to do about it when they don't look the way they should. So things like, is it early, is it late, is it better quality than expected, is it lower quality than expected, how can I help? If somebody is late and they're late because of some reason, can I help to get that done? Within self-managed teams, coordination is informal and by mutual adjustment, and it's real fast, and that's where collective mind comes in. Now the team software process, from experience, is that it is something that will develop, but not by itself. It won't magically come out of the void. It doesn't necessarily happen through the forming, storming, norming, performing stages of a team. You do have to deliberately interfere. The team does need to identify and resolve team issues. The team does need to measure its performance and have some agreement about how to measure its performance. It does need to decide what improvements to make and how to make them, and presumably when to make them. Now, lessons from education from lessons from TSP, that under severe pressure, software engineers will generally concentrate on tasks they know how to do, even if others are more important. We're under pressure, and I'll do what I'm good at doing, and hope someone else takes care of the rest. Thus, when they don't know how to develop firm requirements, for example, or produce a well-structured and documented design, or establish an effective working team environment, they'll generally concentrate on coding and testing. This is what they know how to do. When they're given a clearly structured set of tasks and defined process for handling them, engineers generally follow the process. This assumes that they know how to follow a process, and I guess that's part of the forming of the whole thing. If you have a team software process, the process, everybody becomes familiar with how we're going to do the work. I have taught, as I say, groups of students some form of team software process. I'm gradually getting better at it, and some of the results they come out with are quite startlingly brilliant. So the summary for team software process, that as presented and taught, team software process is based on the engineering paradigm. It addresses some of the social issues of teamwork as opposed to the technical issues, and the team software process works. Not surprising, any rigorous method will work, but team software process works particularly well.